I think we hopefully will be able to understand more about how to design, maybe hopefully I think the computational chemistry and the rational design side will continue to improve, and that it will help us to devise chemical process in a more precise way. But I think that doesn't mean that it's going to replace our intuitive thinking, human being, the creativity. So it's going to be a combination. But I think it's both. It's both between the cooperative activity between the rational design, computation study, and the intuitive, creativity. Hopefully, will let us to discover even more chemical process that we could never imagine before.
I think that we are in a really exciting period. I think that in the case of my field, electrochemistry, it can really play an essential role in building a future society based on sustainable energy. And that comes from the fact that we can convert renewable resources like for instance, fuels like hydrogen by, for instance, water electrolysis. We can use this hydrogen in fuel cells to produce clean electricity. And on the other hand, something that is very exciting and not so much explored, we can also convert renewable resources into high-value building blocks, chemicals, and fuels. We can change the way we produce high-value chemicals, like, for instance, polymers that are produced in the petrochemistry industry, not the most sustainable way. We can do by means of electrochemical devices, and that in a sustainable manner. So it's very exciting.
Well, I think that what would be very interesting in science, but more precisely perhaps in chemical science, is perhaps to try to reduce the energy we use, right? So decrease the large amount of fossil fuels we are using, right? So I think that we should go, and we have to go towards more sustainable processes in the broad sense, from small chemical experiments to large plants and implementation in industry, I think.